Now, in this video, we will go to discuss about one more problem on the projections of laminas. The problem number 103, how to analyze this problem and also how to solve by using the sketchbook. The problem reads as a square plate of 30 mm sides rests on HP such that one of its diagonals is inclined at 30 degrees to HP and 45 degrees to VP. Draw its projections. He says it is the square plate is resting on HP, so obviously we have to start from HP. So, but how to start this problem? Because he has not shown or he has not given any condition that it is the side is resting on HP or corner is resting on HP. But he has given the diagonal is inclined at 30 degrees to HP and 45 degrees to VP. So, whether to keep the lamina in vertical position or it is in the corner position or the side is on HP. Suppose if I consider a side is resting on HP, so what happens we will see. If I consider a side is resting on HP, we can see here A, B, C, D. So once it is considered like this, so what happens? The diagonal AC and you are going to have one more diagonal is BD. So this surface is parallel to HP but still it is perpendicular to VP, it is fine. It is condition is satisfied. But what happens is the diagonals, once you keep in this position, the diagonals will going to become inclined to VP. So once this diagonals becomes inclined to VP, so what happens? You will going to get the apparent length in the diagonal. But what the inclination given is the true inclinations always. So since the 30 degrees to HP, so you are getting the true inclination line. So since it is the true inclination line, so but the what you get here when you keep this side is resting on HP, so obviously the side if it's perpendicular to VP, then the diagonal what you get is the apparent length. On the apparent length we cannot transfer the on the apparent inclination we cannot transfer the apparent length. So on the apparent length we can, on the true inclination line we cannot transfer the apparent length. Hence this problem will going to become wrong. So which is the next position? We have to keep it in the corner positions. Once you keep it in corner position, what happens? You are going to get the diagonal AC which is parallel to VP. Since it is parallel to VP, you are getting the true length in the vertical plane. So once you get the true length in the vertical plane, as the surface is inclined to HP or the diagonal is inclined to HP, so obviously, so since it is the true length and also the inclination given is the true inclination, therefore in the second position we can transfer it directly. Hence this condition is right. So this is how we need to analyze these problems once it is given in the problem. Now, so now here in this case the surface is parallel to HP and perpendicular to VP. As the surface is parallel to HP, so you are getting the true shape in the horizontal plane. And as we see the surface still perpendicular to VP, so you are getting a vertical line. You're going to get a line in the vertical plane. So this is how we will be able to place the initial position, and we can see this corner position here, so that the diagonal is parallel to VP. As the diagonal is parallel to VP, so you are getting the true length of this diagonal here in the front view in the initial position. Now, such that one of the diagonals is inclined to HP at 30 degrees to HP. So what we are doing is you are making the diagonal to be inclined at 30 degrees to HP. So naturally you are getting the true length in the diagonal and also the inclination given is the true inclination. Therefore you can transfer it directly here. So this is 42.4264 and this length is also 42.4264. So now, so here in the second position, as we are rotated by an angle of 30 degrees, the diagonal is inclined, and to this the corresponding top view will going to be written here, which is 36.7423. So as the diagonal is become inclined to HP, so you are getting the apparent length of the diagonal here. And here in the third position, what he says is such that the diagonal is inclined to VP at 45 degrees. So what he is telling is the diagonal which is already inclined to HP is makes an angle of 45 degrees to VP. So here he has given the true inclination, but what you get once it is been rotated here, you are getting the apparent length here. So once you get the apparent length, and here the inclination given is the true inclination, therefore you cannot rewrite the second position top view directly. Why? Because In the third position, the inclination given with respect to VP is the true inclination. So, but in the second position top view, what you have is the apparent length. Therefore, we need to find out the apparent inclination here. So, how to find out the apparent inclination with this procedure which has been explained here. So, first we are going to draw the true inclination line of 45 degree, which is AC1. Then you take the true length of the diagonal, which is AC. You take this, or you can take this, because this length and this length both are one and the same. As AC is the diagonal which is parallel to VP, then obviously you are going to get the true length in the vertical plane. You take this true length of this diagonal with as consider any point and cut an arc on this. So you are going to get C1, and then draw the locus. Then you want the top view apparent length. You take the distance from A to C with the same center, cut an arc on this locus line. So you are going to get AC. Then on this beta inclination line, that is 54.74 degree line, you rewrite the second position top view here, and then write the corresponding front view. So that is what we have shown here. So we have rotated so that on ECC, this is the one where you will going to get this apparent length, and then on this diagonal you keep this square, and then write the corresponding front view. So this front view what you get here and also what you get here, both are one and the same. So this is how, as we are keeping the rotation in the second position top view has been rotating, so that you can see here that point which was C1 dash here, which has moved to C dash here. So this is how you will be able to understand this concept here in 3 dimension. And now how to solve this problem by using the sketchbook. So first, how to do that? First we are going to draw the XY line, which should be a thin line, and you mark this as XY and mark this as VP and HP. Consider any point and draw a horizontal line, and you mark this point as small b. Then by using the protractor, you measure an angle of 45 degree to this horizontal line on either side of this, and then draw this 45 join from B to this 45 degree line on the left side, and also from B to the 45 degree line on this side. Then with B as center, taking the radius of the square, which is 30, cut an arc on this side and also on this side, so that you will going to get this point as A and C. You mark them as A and C. With A as center, taking the radius of 30, draw an arc with C as center, cut it on the previously drawn arc, so that you will going to get this point D. Then you join A to B, B to C, C to D, D to A with a dot line. Then from A, you draw a vertical projector to the XY line, and from B and D, you draw a vertical projector to the XY line, and also from C, draw a vertical thin projector line to the XY line, and you mark these points as A dash, B dash, and C dash, and then D dash in bracket. Then join, as we are joined between A to B and B to C, join between A dash and B dash C dash, both will going to be a dot line, because A dash, B dash, visible to visible is visible, and B dash to C dash, visible to visible is visible. So this is also a corner, and this is also a corner. So it is, you make one of the corners on XY line, you consider A dash, consider any convenient distance from the first position front view, and you mark this point as A dash, and then by using the protractor with respect to the XY line, you measure an angle of 30 degree and draw an inclined line, and by using the compass and take the distance from A dash to C dash of the first position front view, and you transfer from A dash on this 30 degree line, so that you are going to get this point as C dash, and you mark this point as C dash here. Then draw, then measure the distance from A dash to B dash by using the compass, and then transfer from A dash on this 30 degree line, and you mark this point as B dash and D dash in bracket. Join A dash to C dash with a dot line. And now you draw a vertical projector from A dash and draw a horizontal projector from A, and these two lines will going to intersect at this point. You mark this point as A, and draw a vertical projector from B dash and D dash, and draw a horizontal projector from B and D. These two lines will going to intersect at this point B and also at D respectively. Draw a vertical projector, vertical thin projector line from C dash, and draw a horizontal projector from C in the first position top view, and these two lines will going to intersect at this point. You mark this point as C now. Then once you mark this, then join A to B, B to C, C to D, and D to A with a dot line. Now you take any convenient distance from the XY line, from the convenient distance from the XY line, and also from the second position top view, and you mark this point here, and then draw a horizontal line. Then by using the protractor, you measure an angle with respect to the horizontal line of 45 degrees, and then draw an inclined line. So this is the true inclination line. Then you have to take the true length of the line and take the distance from C to A of the first position top view, or you measure the distance from A dash to C dash of the second position front view, and then transfer from A and cut an arc on this 45-degree line, so that you will going to mark this point as C1, and then draw a horizontal line, and you measure the distance from A to C of the second position top view with the same center A, cut an arc on this locus line, so you mark this point as C and join A and C with a thin line. And then again, by using the compass, you measure the distance from A to this point. From A, transfer that onto EC line, and then you mark this point here. Then you measure, then to this inclined line you draw a perpendicular line. Then once you do that, you measure the distance from this point to B and also from this point to D. Both these two lines will going to have the same distances, and transfer from B towards the left, transfer from this point towards the left side to get this point B, and also from this point towards the right side to get this point as D. And you mark this point as B and D. Then join A to B, B to C, C to D, D to A with a dot line. Then draw a horizontal line from horizontal projector thin line from A dash, and draw a vertical thin projector line from A. Both these two lines will going to intersect at this point. You mark this point as A dash. Then draw a horizontal projector from B dash and D dash, and draw a vertical projector from B and also from D. Both these two lines will going to intersect at this point B dash here and at this point D dash here. Then draw a horizontal projector from C dash and draw a vertical projector from C. Both these two lines will going to intersect at this point. You mark this point as C dash. Then join A dash to B dash, B dash to C dash, C dash to D dash, and D dash to A dash with a dot line. And this is how you will be able to complete this particular drawing by using the sketchbook. So, and show the dimensions of this 30 and also this 30 degrees and this 45 degree, and show this dimension as beta. So this is how you will be able to analyze and solve the problem by using the sketchbook. Thank you.